All right, so we're asked to divide when there is a radical in the denominator. So I have two examples here, one where there is only a radical in the denominator and where there's radicals in the numerator and the denominator. So before we start dividing, there are some rules that we should keep in mind. When the square root of x is multiplied by the square root of y, you can rewrite them under the same root, assuming that the roots are the same, aka square roots. So square root of x times the square root of y is always equal to the square root of x times y. We also have another rule here that states that the square root of x times the square root of x, aka the square root of x times itself, is always equal to just x, because this is equivalent to saying the square root of x squared, which just cancels out these two terms. So let's start dividing. So I'm going to do the first example here. So we are given 6 over the square root of 7. And we don't want to change this term, but we do want to get rid of this radical on the bottom. So the only way to multiply a term without changing it is by multiplying it by 1. Obviously, we can't just multiply it by 1. We have to do a term that is equal to 1. And we can use this second rule here to our advantage. Because if we just multiply the denominator by the square root of 7, aka by itself, it's just going to equal for the denominator in the answer to just be 7. But for the square root of 7 on the denominator, to be equal to 1, we have to write the same term in the numerator so this term equals 1. So we already established that the denominator square root of 7 times the square root of 7 is just equal to 7. And for the numerator, we cannot combine these two terms because we cannot combine a regular term and a radical. So we're just going to have to leave it in this form right here. So it's just 6 times the square root of 7 over 7. And this is the most simplified form of this term. So the 6 over the square root of 7 is equal to 6 times the square root of 7 over 7. Now, for the second example, we have a radical in both the numerator and the denominator. So it's 2 root 3 over root 2. And we could do the exact same thing. We still want to multiply it by 1, so we're going to do square root of 2 over the square root of 2. And this is going to equal the denominator to be equal to just 2. And in the numerator, we have these terms 2 root 3 times root 2. And you notice that we can use the first rule to kind of combine these two radicals here, because we don't want two radicals. We can just combine it into one. So we have to keep this 2 here, but we're going to multiply these two together. So this term is going to equal 2 times the square root of the inner terms. So 3 times 2, which is equal to 6, the square root of 6, all over 2. And you can simplify this even more because notice we have a 2 in both the numerator and the denominator. And since this is not being added or anything, it's just being multiplied, we can actually just cancel these out. So your final answer for this will just be the square root of 6. So 2 times the square root of 3 over the square root of 2 is equivalent to square root of 6.